It is my pleasure to hand over now to Ilya, who will drive us through AI, autonomous racing, and public transportation. Ilya, the floor is yours.
Hello, everyone. I'm Ilya Shimchik, team principal at Constructor Racing. I'm happy to share with you our experience in autonomous racing and how it correlates with public transportation and what research we are doing here in Constructor. Please, next slide. Yeah, here you see like a quick picture of teams participating in autonomous racing event that happened at the end of the April, just slightly more than 1 month ago. It happened in very famous Yas Marina Formula One track in Abu Dhabi. In this track, Formula One cars competing. We were competing with slightly different types of car, but it's quite similar to Formula One. Let's go to the next slide. So let's cover what's actually A2RL, Abu Dhabi Autonomous Racing League, and what's autonomous racing is about. So it's quite a new type of event. Not, I believe, very few of you probably kind of familiar with the autonomous racing event and sport, how it's like evolving. So let's dive deeper into this topic and share more details about the event. Next slide. Yeah, so here you see like a quite high-level picture. So we have full-scale car, full-scale track, like real track, real car, but we have all attributes of racing team except one piece. We don't have driver. So it's fully autonomous, only software drives the car, no remote control, no any like simulation that's people can sit behind the screen and control the car remotely. So it's not allowed, it's not possible. All cars fully autonomous and teams competing on Formula One track with this super Formula car. That's the car built for Japan Promotion League. It's very limited amount of cars built by Dallara. It's manufactured in Italy. And Abu Dhabi Autonomous Racing League provided this car for this competition, and we competing in this car. So just a quick comparison, like where is this car in terms of performance comparing to Formula One car, because it's the most known example. So basically it's a second after Formula One car. One car is built like unique. Each Formula One team has unique cars. They build it by hand. There is no identical cars in Formula One teams. This car is built in small scale, like a small production. All car identical, but they're very fast. And as I mentioned, like after Formula One, probably that's the fastest car in racing. It's quite similar performance to Formula 2, but I would say that's the fastest after Formula One. So top speed for this particular, can you go back like just few moments about team and about price? So all teams develop only software with which we compete. We don't do anything related to mechanical part of the car. We're not allowed to change, I don't know, like suspension parameters, to change the gear, to change their engine or tune their airflow of the car. So everything identical, and teams competing only in AI. So it's pure competition of software, of brains of the teams, I would say. So yeah, let's go next. So top speed of this particular car is 300 kilometers per hour. Again, comparing to Formula One, in Formula One top speed 350, so 50 kilometers more. Car quite lightweight, it's less than 700 kilograms. And as I mentioned, it's built from Dallara manufacturer in Italy for Super Formula Championship in Japan. And then it's also provided by Abu Dhabi Autonomous League to compete in this type of competition. Let's go next. So we have the car that's built for human, and human should drive this car. And in order to control this car with software, we need to add additional equipment. So basically, we need to provide at least computer that can execute the commands, execute the AI. And also we need to provide this computer ability to understand what's happening around the car. So we need to equip sensors. So this car equipped with different types of sensors, and that's information that generating this sensor is quite huge and tremendous. So for example, we have 3 lidars facing like forward on the side. You see here in the picture, on the right side, that's one LiDAR facing forward, and you see on the side there are one and on the left and on the right, one LiDAR also installed, facing slightly backwards and on the side. Also car equipped with radars, that's 4 radars for each side, forward, back, left and right. And also we have cameras, 7 cameras that can provide car ability to see like 360 degrees around. And we have quite precise localization technology like GNSS IMU. It's basically provides us quite precise position of the car on the track with some noise, I would say, because we can't rely only on GPS. It's quite noisy, not uncertain, so that's why we need also sensors. So combining everything together, we have computer, we have sensors, and we have ability to control the car. It's called drive-by-wire, so we don't have any mechanical arms or legs from driver, so we need to control brakes and steering by some motors and actuators. So that also was modified for this car. So everything else, as I mentioned, it's pretty standard super Formula car that's used in other championship. So probably not everyone of us familiar with Japan Promotion League, but in Japan, the Super Formula Cars and Super Formula League is very famous and very interesting event. Let's go next. Let's see a quick highlight how it was in Abu Dhabi in the event. Could you please play the video? Okay. So event, it's not only about autonomous racing, it's about additional activities that happened on the track. For example, here you see like it was like small scale cars. That also was side competition between schools and students that can drive the car. Just now you saw the drone, like full scale drone with human inside that can drive the track, and also some side event of competition of racing drones. So human controls the drones and they're racing. Also, there was additional event about competition. You see it in the screen, human versus AI. So one car is human, another car is artificial intelligence, and they were competing who were faster. As of now, human is faster, but there is like there is not slight, there is a chance that in coming 2 to 5 years, AI will be faster than human. Let's go next. So here are the teams that competing. So as you understood, like Constructor Racing, Constructor team here, and also many well-known universities and very smart people around the globe competing in this championship. People from Technical University of Munich, University of Politecnica Milano, University of Modena, University Beijing Institute of Technology from China, Khalifa Institute from United Emirates, and TIA Institute from Abu Dhabi. So it's well-known institutes and universities competing in this championship. Next year, the number of participants are going to grow. So probably it will be up to 12 teams. So plus 3 new teams will join this championship. And the competition should be more interesting and more challenging. Let's go next. So let's talk about our team and what we did during this racing event, what helped us to show quite good result. Next slide. So we have a good experience participating in autonomous racing. So actually we started not only this year, we started quite before. So first we joined autonomous racing championship called RoboRace in 2020. It was quite different type of the car. It was fully electric, but it's called closed wheels. So we see here in the photo is open wheel car. In RoboRace it was closed wheel car, fully electric, also driven fully autonomous. So there is no remote control. It was different types of competition. For example, it was virtual objects on the track that we have to avoid, have to overtake, and have to compete. And basically, we are showing the best lap on particular track. For example, in Las Vegas Motor Speedway, in Europe racing track, we are competing and showing best lap, trying to avoid virtual objects and collect collectible objects. So recently, with RoboRace, it was lasting like more than 2 years, and we were champions of Rob Race season beta. So almost each race in Rob Race in season beta has been won by us. It was quite successful year for us, but unfortunately, Rob Race right now not continue to deliver new events. So that's why we joined another racing league called A2RL that I was talking just a few slides before. And we started participation and in preparation of our technology, of our racing software for this event at the end of 23rd year. And then in April, we already showed result and got the second place in A2RL grand final event when 4 cars were competing in Yas Marina track in fully autonomous race. We started fourth, but then eventually we took a few cars and got the second place. Let's go next. So just quick overview. What happened? You can see on the right side of the screen like a short video about our team, just give you a feeling what was happening during the event. Basically, as I mentioned, it's very well-known Formula One Yas Marina track. It's more than 10,000 visitors came to the event. It's a very good result considering that next the most visited event in this track is Formula One. Other event gathers less amount of people, and it's more than 1 million people, around 1 million people viewed this event online. Let's cover a bit type of competitions, type of categories of events that happened here. So first of all, it's quite simple to understand the best lap. So one car on the track, we have 50 minutes on the track. During these 15 minutes, we should show the best lap. One of the challenges that's for this type of car, for this type of vehicle dynamic and like tire dynamic, we cannot show the best lap on the first lap. So we should warm up the car, warm up the tire, warm up the engine, and then probably at the end of this 15 minutes, it will be our best lap. So that's like one category, one type of event, and that's were happening in Abu Dhabi. Then next type of event is suited mostly to practice and to show the ability to overtake. It's called attack defense, when 2 cars was at the same time on the track, and the task, so it's more like a duel. First car starts as a defender, car behind starts as an attacker, and the purpose for the attacker car to overtake the defender. And then they have 2 rounds, first round, and then second round they switch. So cars that was defender, start as attacker, and to overtake. So summing up the points for each of their attempts, we get the winner of this competition of attack defense. And then all the teams were split on pairs, and each pair were competing and showing them and collecting the best points for this type of event. So it's purely for taking. And actually, during this type of event, we succeed and we did the first autonomous overtake on Formula One track that's ever happened. So basically, it's the first autonomous overtake on Formula One track, official overtake. And then we had multi-vehicle event. It's called also grand final, when 4 cars was on the track. And the idea was quite similar to the regular racing, when we have 4 cars competing to finish as first, to finish the first. So that's 3 categories. And only the last category, like multi-vehicle event, 4 cars on the track, was shown during the event. Other 2 categories happened just a day before. It will happen online, but offline, but you can find the result on official video from A2RL. So one interesting fact, so I already covered a few details about speed, about the car, but as I mentioned, the sensors and car generates quite a lot of data. So for example, it generates for 10 minutes of run, you get approximately 100 gigabytes of data, and it's actually compressed and reduced. Basically, lidars, such sensors as lidar, generates quite a lot of data points that leads to huge amount of data set. And yeah, probably I need to make a bit this definition, or define a bit what's like a lidars and radars. So I believe cameras is quite obvious. LiDAR, that's the type of the sensor that's measures the distance to the point. So it has a lot of laser beams that can return you the distance to all objects around you. So it's 3D view on of distances to the objects around you. So the car can understand what's the exact distance to the objects in front of the car or on the side, so like 3D view. So with these sensors, we can generate map of the track, and we also can detect other vehicles based on the lidars. Also, radars, it's quite similar result. It also returns the points with distances, like in 3D, to the objects, but it's just different principle of work. So lidars, it's mostly lasers, laser light. Radars, it's radio frequency. So different physics used to gather this amount of data, to this type of data. And then GPS RTK, it's almost the same as GPS, but with a bit like slight difference. That's much more accurate and can provide the precision of the sensors up to 2 to 6 centimeters, but in perfect condition. On the track, it wasn't perfect condition, so we a lot of get our data or resulted location of our car somewhere close to the moon. So it's not very precise and can jump sometimes randomly to any other point. So that's why you need not only rely on one sensor, you need to combine all sensors together and understand where the car is. Next slide. Yeah, so here just quick overview, like what was done and how it was. So here you see 2 videos of tests. I call this actually like successful tests because during the tests, the purpose of the test is to find something wrong with your software, something wrong with the car, and push the car to the limits of its performance. So push it to the failure, basically. And ideally, we need also not to crash the car. So basically, that's 2 videos satisfies this definition. We found the limits of the car, but everything's safe. Car is not crashed, and we luckily understand a bit more of the car and of its performance on its abilities. So to recap, so we spent 2 months of integration of our software to the car, and probably last part of these 2 months, about 2-3 weeks, was spent on pushing the car to its limits of its performance, to the limits of handling. So to understand what's car capable to do, what is not capable to do. Also, we had such called VDA testing. It's vehicle dynamic area. It's basically a flat surface, maybe like a 200 meters by 300 meters, where you can just test a car on this area without any turns. You can generate all trajectories that you want. It's worth to cover a few issues that happened with us during the test. So I would say that a lot of issues is due to the fact that we deal not only with software world, we also deal with real objects, with real physics, with real world. So that's why system integration and dealing with imperfection of real worlds, real physics, that's what takes time and needs that. So let's go next. Let's cover quickly why we need this autonomous racing. So basically, next slide, I believe it's quite obvious that autonomous, that's the future where we are already. It's unavoidable that most of the car at some point will be autonomous because it's saving time, saving human health, and reducing number of accidents, saving time and money. So basically, it's I believe not. It's quite clear that that's our future. But why we need racing? So can you go to the next slide? Before I describe why we need exactly racing, so just quick recap, maybe a few of you familiar what's levels of autonomy. So boundaries between, for example, level 2 and level 3 is not very clear, but let me just highlight the bigger picture. So the huge difference between level 3 and level 4, that's everything that's level 4 and 5, it's fully autonomy, and AI is fully responsible. So software responsible for anything that's happened with the car. Below level 4, like level 3, 2, and 1, and 0, human who's sitting inside the car is responsible for any accident. So that's why it's quite hard to jump from level 3 to level 4. Level 4, just to clarify, it's conditional autonomy. So it's like not fully, it's autonomous in particular area. So for example, in our racing event, we are fully autonomous with no human interaction. Our software is responsible for everything that's happened with the car, but we only autonomous in this particular racing track, in this particular racing condition. So for example, if we see any strange object on the track, bicycle or pedestrian, our software will be confused. So we not train our software for the cases that exist in public roads, but there's quite a huge overlap that we have with public road. Let's go next. And basically that's one of the reasons why we are doing autonomous racing. So basically you might see that we do it only like mostly like for fun because it's really interesting, only for sports. In any sports, the goal is to be the first and to get the highest place as possible. But also we race with purpose, and for us purpose is to transfer technology from autonomous racing to the public cars. And one of the areas that we see is really promising, that's safety of autonomous car, because we understand quite precisely uh, dynamics of the car, how to drive it, how to drive the car at the limit of performance. And that's exactly the conditions that we see when we need to avoid, do some emergency maneuver in our public car to avoid the accident, to avoid obstacles that appeared. That's the condition when we need this understanding of the car, and we believe that's one of the intersections with public cars, and that's what we are working on. Also, we need such events for facilitating and for training the researchers, for training the AI professionals, for training the people who understand the self-driving and can develop this technology forward. Let's go next. Yeah, let me cover just a couple of slides about technologies that we use. It's a really high picture, so quickly describe. So of course we have path planning and path following. So car should understand and should predict where to drive next and execute this plan. So basically you follow some very known framework for robotics. It's like a sense, think, and act, like three main blocks. So we sense with our sensors, then we plan our trajectory, and then we execute this trajectory. And for that, we use some different techniques and different submodels like mapping, localization, sensor fusion, obstacle avoidance for overtaking the car. And also we need to understand quite precisely to execute the plan. We need to understand precisely the car, its dynamics, its capability. And so we need to control the car at the limits of handling. So that's why we need to understand physics and dynamics of the racing car. Let's go next. Just a quick example about technology or result that we have and that we are using during the race. That's how car sees the racing track only based on lidars. So I mentioned lidar, that the sensor that returns distance to the objects near the car, and then you see how car sees the track. So we got this map when we drive slowly on the track to get as much data points as possible. And then offline, we process these points and we created 3D map of the track. And then we can drive this track based on this map and based on lidars. Let's go next. Another like a important subsystem, that's generation of racing line. So racing line, it's a trajectory that's racing car should follow. It's quite different from usual trajectory because we need to take into account the dynamics of the car, configuration of the track, including inclination of the road surface as well, and speed of the car, of course, and also friction limits of the track. Taking everything into account, we can generate the ideal racing line, which leads to the best performance, to the best lap on the track. So we need to calculate this racing line offline because it's quite time consuming and need to optimize this line for particular track. And usually, if you're familiar with racing, probably you see that during the racing, all of the cars following approximately the same trajectory. If they are not overtaking or not avoiding obstacles, they following the same trajectory. So that's actually what we also need to do. We need to prepare this trajectory and understand the trajectory for a particular car for the given track. And yeah, another like parameters for it, it's like a 2D or 3D, so we can create like 2D racing line or 3D racing line. Also some safety margins from the track boundaries we need to take into account to understand how precise our control can be during the execution of this racing line, because we believe there is some uncertainties from sensors, uncertainties from our control module, so we need to take into account and add some safety. So yeah, let's go next. Next slide. Just quick overview about our racing car results. Next slide with the video. So that's our Constructor racing team. As I mentioned, we participated in few types of events. We get a fourth place on the best lap competition, so we have room to grow to improve our best lap. But despite on it, we showed third place on autonomous like attack defense, and we showed and achieved the first ever overtake on autonomous racing track, despite the fact that other cars, that's example of other overtakes. And during the final round, because we showed fourth place, we started on the first place, but eventually we finished second into the grand final event. It's quite a good result, and we striving to achieve better result during the next event that probably happen next year. Maybe something will happen earlier than next year, but for sure next year in March, same track, Yasmin track, you can see and visit this event in Abu Dhabi. And next slide. Yeah, just like quick summary. So as I mentioned, like a first autonomous overtake, only one car that finished the multi-vehicle grand final event in fully autonomous mode without using joystick. Other car should use interact with the car remotely just to place the car in some precise position. But yeah, overall we got a second place in multi-vehicle race, third place in attack defense, and fourth place in time trials. Yeah, that's it. And next slide. Yeah, thank you. I believe if you have questions, we can cover a few questions right now or at the end of the presentation.
Thank you very much, Ilya, for this fascinating presentation. Just listening to your talk, I felt like being a part of the team right there at Abu Dhabi on the racing the racing competition. So thanks very much. We do indeed have a few questions from the audience, and I encourage the others to write down their questions in the chat function. So one of the questions that we have received is, what do you think the public transportation will be within the next 10 years, and what would be the role of the AI within?
It's interesting question, and it's hard to predict the future, especially when the world is changing quite fast. So I really believe that most of the transportation will be autonomous. It's hard to say like whether it will happen in 10 years or like later, because right now we already have autonomous cars, at least partially autonomous, that can substitute the driver during the highway driving or driving traffic jam. And there is already such options that's autonomous car already in place. But yeah, we are going towards the direction of fully autonomous car, and it will happen, I think, step by step. So some regions in the cities will be only available for autonomous transportation, and then it will be eventually extend to any other to more and more areas. So that's how I see. It's hard to say like 10 years or less or slightly more, but eventually it will be fully autonomous.
Indeed. Thank you. Another participant, Adam, is asking us whether any vehicle was damaged during the race.
Yeah, there is quite a lot of crashes actually. Probably you can find a few like highlights with crashes about in this event because that's really like first autonomous racing event done in this scale, and team joined the championship and developed the software. You know, like a software is very immature. Even if you test it like for 2 months, it's still not enough. Not enough time, not enough data sets to collect, to analyze, to understand all conditions, and that's why we have crashes. And it's quite usual to the racing. If you see the racing events when human, there is a lot of crashes. I mean, not a lot, but like crashes happen in almost each event uh, in racing. So here as well. So it's not a different from any other human drivers, human championship. So yeah, you can find probably more videos with crashes in internet.
Thank you, Ilya. I'm just looking through the questions that are coming in. Another participant, Reda, is asking us what current automotive companies working on autonomous driving could learn from your experience. So,
So basically, as I mentioned, so it's research still in progress. The main intersection is how to control the car at the limit of its performance and understand its limits, what's possible to do with the car at such speeds, at such accelerations, and then transfer this knowledge to the public car to help to avoid like accidents in more efficient way and increase the rate of success, like avoided accidents. Um, yeah, I see like next questions about safety measures, like what safety measures are employed by autonomous vehicles to prevent collisions and ensure safe navigation. So it's quite wide topic. So I can, if it's about autonomous racing, we employ like a detection of other objects, other obstacles on the track, and then plan our trajectory avoidance, obstacle avoidance technique to overtake it. For public cars, there is much complex and many layered systems with different backup solutions to basically detect collisions and then plan safe maneuvers. So as you see, like all sensor used for these maneuvers, like lidars, radars, cameras. In each sensor, you can detect obstacles, you can detect objects, then you fuse this data, filter it, and then do the avoidance.
thank you, Ilya. We have a lot of questions coming in. I'm just looking now in the Q&A webinar chat. So another question refers to what kind of software did you use to analyze the reading from the sensors? Did you get all full set of sensors to test on before the competition? And a subsequent question from Adam is, what kind of machine learning AI models have you used? How did you train them?
So software, so it's basically our software. We develop software to analyze, to process the data from the sensors. Most of the software, like written in C++, we to increase the speed and of computations and save the more performance for other tasks. Yes, we work with all the sensors. What kind of machine learning models have used? So it's like quite standard, I would say, like convolutional neural models. So we don't use transformers because we need to execute most of the code online with huge constraints on performance. So we have like quite not a lot of time to process all the data. So we use like separate networks for lidars, for cameras, for radars, and then fuse this data into the one model. Also, we use some models for prediction of position of other car. train as usual, like as any other like neural network train. So we have training data sets providing their training data. So labeling this data, sometimes we label in more like autonomous. Sometimes we label by hand, sometimes we label automatically. So yeah, so it's quite standard for this. There is nothing like a huge. So we don't use ChatGPT because it should be done on board on a car without connections to some such APIs as ChatGPT, and we don't need it actually. And there is huge constraint on their performance.
I think we can still take a few more questions before moving on to the next session, and I'll address Mohammed's question, and he is asking for what it was used the LiDAR function for locating other objects. Did you use it for any additional functions?
Yes, we used for two main like functions is to actually three. So first we created a map of the track with lidars. Second, we use this map to localize the car on a track. And third, to detect other obstacles. And it's worth to mention that we're not only using lidars for these functions. So for the map, for example, we use also precise GPS to create the map. We use other sensors. So basically, to increase their accuracy and redundancy of the system, we merging different results from different sensors into the one common picture. So for example, camera sees the obstacles, LiDAR sees the obstacles, radar sees the obstacle. Then we combine all sensors together and understand like a fused picture where is the object located. So that's how it works, and that's for what we used LiDARs.
Thank you. I see here another question referring to a unified moral code. If you think that it's needed for autonomous vehicles, and is it possible that having different ethics inputted into the cars could cause more accidents, perhaps? So a question on the moral codes or the ethics used.
I understand the question. So it's quite open questions still, so I'm not sure that I will be able to answer it. I can share only my opinion. So probably right now it wouldn't be like a common opinion that each car should follow like one of their like ethic codes. For example, to what put priority, to save the passenger, to save the driver, or to save the pedestrian? Because it's more like moral question. It's not questions to autonomous vehicle. It's questions to the human. Because as a driver, human do these decisions, and it do the decision based on his own philosophy or his own instincts. So, and this decision could be different for different people. And I don't think it's quite easy to answer right now, especially when the whole industry of self-driving is quite young. Maybe eventually, like at some point when we mature in these questions and questions of ethics, we'll be able to make a unified ethics for autonomous vehicles. But basically, it's philosophical question, so it's not answered by philosophers. So I'm not sure that I will be able to answer this as well.
Thank you. And I think we'll take the final question for Ilya now from Ibrahim, who's asking if autonomous cars could be a solution in the third world countries or in developing countries where road congestion is a regular problem. If you have any
Yeah.
on that.
So I think the main point is about like a complexity of driving in different road scenarios and different road conditions. So not only driving some more like a controlled or regulated roads, but driving chaotic conditions. So I think answer is yes, and it's about all about data sets, about data that we can collect and then analyze and then train the algorithms to drive in such conditions. So yes, there is no technical limitations. What's needed is data sets and time to develop better algorithms that's suitable for this condition. But basically, I don't think that's it's unsolvable. I believe some companies are already working in these countries and creating the solutions.
Great. Thank you, Ilya, and thanks to everyone for your questions. So I would just like to add that Ilya's work on autonomous car is one of the many exciting projects that my colleagues at Constructor Group are working on, in particular here, Constructor Tech, Constructor Racing. And as a future master student, you will have the opportunity to engage with such topics, both through your coursework and internship opportunities. And all the details will be covered in the next sections of the webinar for that. I'm happy to introduce our next speaker, Professor Manuel Oriol, who will provide you with an overview of our institute and of our master programs.
Hello, everyone. I hope you can hear me well. So it's my pleasure to come to this presentation and introduce the master programs at the Constructor Institute. Please, next. So about the Constructor Institute, we are part of a Constructor group. As you noticed, we have various people in the group, various sister companies and universities. The group was founded by Serge Bell, who is a highly successful entrepreneur, founder of Acronis, Parallels, Acumatica, etc. We're located in Schaffhausen, and it's the main research and education branch in the Constructor Group. Sorry, I'm reading a little bit. Together with our sister university, Constructor University, you could see on the slides from Ilya that there was quite some branding of Constructor University there. We work together. Next. We have a strategic advisory board who is made with many leaders, including some Nobel Award recipients, some professors and pioneers of quantum in some cases. Thank you. Next. Next, sorry. Yeah. So why should you join Constructor Institute? Of course, one of the reasons is you can work with Ilya. He's here and he's happy to have students, right? But apart from that, you can see that we have programs which are a union of programs on computer science, quantum computing, software engineering, and some digital leadership. They prepare you for various positions, including leadership positions, but also for teaching, research, and some industry. Next. So this is a sample of our course of one of the master's programs. So this is the master's program in computer science and software engineering. Software engineering and leadership. And this is the master's program that Victoria has been following. She will be talking to you afterwards. What is interesting here is that you have a strong basis of technical knowledge. So you're becoming a much stronger computer scientist or software engineer. You also have something that is seldom included in other programs, right? So you have a management part, so track, where you have product vision, product design, change management, and leadership, where you can actually acquire a customer-centric mindset. And when I graduated with a master's degree a large number of years ago, then I didn't have these two sides, the two last parts, so the management and leadership. I had some introduction, but it was one course, right? And I graduated in 1998, right? So when you consider this, you might realize that the internet revolution happened in 2000 something, right? So when you knew computer science at that time, you could have actually started a company and potentially becoming very, very wealthy. I didn't, because I didn't even know it existed, okay? Because the dream was so far away. So I hope that in this program, you can see that the hope is closer. After a number of years working in industry and in academia, I can tell you it's not so far away. It's not too far from you. Next. So we have a number of reasons why you should be studying with us, but one of the ways is, or one of the reasons is also that we have some innovative learning. So typically, many courses require you to be doing blended reverse classroom. We also have industrial projects. So that's what I hope you will do with Ilya. You have world-class instructors, of course. And then you have advanced learning as well with Constructor technology. So with our partner institutions, we have a platform that helps us. Next. So this is one of the two programs to have these two masters. So computer science, software engineering, and leadership. I mentioned it already. And I'm also the program director for the quantum software engineering and computer science. You see, there's a strong software engineering and computer science all the time, right? But basically, here we take a strong software engineering and computer science background, and we also have a strong part on quantum computing, because we think that quantum computing is going to start some revolution in the computing area, and that, well, if you learn it before the others, then you have a competitive advantage. Next. So the courses, both of them, they are 120 ECTS credits. Just in case you don't know what that is, that's a European standard for education. Each ECTS credit is equivalent to 25 to 30 hours of learnings, and that includes lectures, but also personal work, right? Then you have three ways of doing it. Either you go through 4 semesters, or you try to squeeze everything in 3 semesters and you do your thesis over the summer. And also a little bit on the other side, so in the spring before and in the fall. Or you try to do it part-time and it's up to 6 semesters, and then we have to discuss how you arrange your learnings so that it makes sense. I think, Victoria, you did it in 4 semesters mostly, right?
Yes.
Yeah. Next. One of the specificities of our program is that we have something called the Capstone Project course, and I'm teaching it. So I'm one of the best people to talk about it. I'm really passionate about this course. This is a course that is spanning over 3 semesters, basically. So it's 3 different courses, but in practice, it's one course. You start from a point of view where you don't know what you want to do, and you try to finish with something that is as close as possible to a product. Next. And along the way, what you do is you have the first semester where you do a proposal step where everyone proposes ideas. Then you choose concepts. So we have a way to choose the best concepts. You create mocks, you make initial proofs of concept, and you talk to stakeholders. So you talk to customers right away. And this is usually an eye-opener because everybody has genius ideas until these ideas become considered by people who might pay you. And when you do this kind of change of mind and you think, would I be paying for this? Usually when it's your idea, you will lie to yourself and say, yes, I will. But when you talk to people and you say, okay, now, you want to do it, will you give me $10 per month for this? Usually there's a change of mind. Usually people start questioning and start saying, well, no, actually, I don't use it. Right? So this is the first semester. The second semester is where you start really the development, and you do the architecture of your platform. You continue talking to customers and you develop. And the third semester is where you integrate some more advanced features like artificial intelligence, cybersecurity, and if you go for the quantum, of course, you will actually do this project for the quantum, of course. So it's going to be everywhere quantum. What is important to know is that when you might see capstone project courses in some other institutions, usually they are 1 semester, and usually they are one group of 4 people, right? Or 4 to 6. That's what I could find out. There's only one other university that has indicated that they do it the way we do. They do 1 year, and it's a university in the US, which is a naval academy. So unless you want to become a US military personnel, then I don't recommend you take it. What is also important is we actually do it in groups of 20 to 25 people. So you have what is called a tribe, and you try to make a product with this very large group of people. And this is really hard because working with 2 or 3 other friends, you know, when you do group work, what happens is one of them is doing nothing, and that's okay because everyone likes that person. 2 people are delivering like crazy, and the third one is making the presentations. Now, when you have a group of 25 people, if you have 20 people who do nothing, you know, that's a problem for the 5 people who remain. So we learn how to track, how to evaluate, how to include or to understand how to get everyone to contribute, right? And we do that in a safe environment because we are a teaching institution, right? When you do this in your first company, of course, this is not safe because you might simply, you know, destroy completely your idea of a product, right? Next. So this is what we had the first year. The whole cohort was 1 tribe, and they developed an application which is called Easy Peasy. They didn't finish the product in the sense that they didn't deploy and have customers, but they were very close. So you can imagine this was during the pandemic, so people were really eager to cook at home, right? And they had a strong competition.
Thank you very much to both of you. We also have a number of questions that came in, but I think we can answer them after Caroline's presentation because most of them refer to the admission process, some further details also about our pre-master program. So I would say, please, again, thanks for your questions. Feel free to put them in our chat function. I'll give the floor now to Caroline, and we'll get back to all of these questions afterwards. Caroline, the floor is yours.
Thank you very much. So indeed, I'm happy to give you more information on the admissions process and a little bit more about why student life and why we love Schaffhausen in Switzerland. So in the next slide, you can, we've really tried to make the admissions process simple and easy. So we have our application portal where we ask you to submit required documents. So 4 required documents: a diploma and transcript, a letter of motivation, a copy of your updated CV, resume, and ID passport, and official ID or passports. And once we've received those documents, then we let you know if you've moved to the next step of the admissions process to do a technical interview. And this interview is about 20 minutes long, where it's a 3-part interview where we do have, you have a chance to quickly introduce yourself and give us more information about your background. And then one member of the faculty will ask you some questions, technical questions related to computer science and software engineering. And then student applicants have a last chance to ask their questions to us about the application process in the program. And so once we've scheduled that interview and done the interview, we get back to you with our admissions decision. We will either send you an email with an admissions offer or a rejection email. And in this case, you might be eligible for our pre-master's program. And I believe we did have a question about the pre-master's program, so I'll be happy to to go more into detail once I've gone through the full the rest of the presentation. And I see this was my typo. June 15th is the application deadline, so in about 10 days. And if for any reason you can't submit your documents by that deadline, please do be in contact with us, and we can see if it would still be possible after that date. So we can move to the next slide. So here you see the tuition fees for the program. So it's 10,000 Swiss francs, so the equivalent of $10,000 per year for EU and EFTA students, and 20,000 Swiss francs dollars per year for non-EU EFTA students. In some cases, we are able to give merit-based grants, and that is something that we communicate to applicants once, if they're admitted with their offer letter. There's no need to apply separately for that. So in the next slide. So here we can talk a little bit more. We've spoken a little bit in particular with Victoria, but here's a little bit more information about why we love Switzerland and why we are in Schaffhausen. So Switzerland itself is consistently voted #1 country in the world because high standard of living, a number of opportunities, and we see this especially in the IT industry, and of course the natural beauty that Victoria was mentioning. And Schaffhausen in particular is a very innovative city, canton in Switzerland. For the past 25 years, the local government has really invested in the economy and has attracted many companies, created many jobs. And for that reason, we really find that it's an amazing place for our students to live and study and have networking opportunities. It's also, again, as Victoria mentioned, walking distance to the largest waterfalls in Europe. So it's a natural beauty, and so close to Zurich, 40 minutes to the city and 1 hour to the airport. And you'll see in the picture just at the tip of Switzerland, so surrounded by Germany. Again, you can walk to the waterfalls, and you can also walk to Germany from Schaffhausen. In the next slides, I think you'll see, yes, some pictures of our campus, the waterfalls, and our campus here. And in the next slide, you'll also see some pictures of our students. I don't know if I spy Victoria in any of these pictures, but indeed some of her classmates. And some of these are taken in our student housing that we have. That's an option for students if they like. And in the next slides, I think, yes, just a few more alumni perspectives that really highlight the things that we have been talking about in the last half an hour or so. The combination of technical and leadership business skills, the flexibility, the small class sizes, and the fact that you really get quite a lot out of being in a small community that's really there to help you grow academically and professionally. And so I think this is the next slide. I think it might be the end indeed. I would be happy, I as well as the other speakers would be happy to take any remaining questions at this point.
Yes, absolutely. We have a few questions that came in, and we can address them. We still have a couple of minutes left. So one question refers to our pre-master program, the Foundation of Information Technology, excuse me. If anyone would like to say a few words from our speakers, perhaps Manuel?
Yes, of course, the pre-master program. So what do you want to know about it? What it is in practice? So essentially, this consists in 8 courses, right? And the goal is, imagine that you have some understanding of coding, you have coded before, right? You have programmed, but you're not a completely proficient computer scientist. It can be for several reasons. In some cases, because your institution didn't give you enough comparatively to the level we expect. But it can also be because simply you graduated as an electrical engineer or a physicist, and then you realized that, well, you want to be a computer scientist, right? So we give you the necessary knowledge to enter and have good chances of completing the master's program. Good chances means you have all the chances to be successful in the master's program. And in that program, I'm teaching a course which is on theoretical computer science, or theory of computing, sorry, it's called. And so, for example, if you have never done theory of computing, you will learn many things, like what is lambda calculus, what is the Turing machine, how to calculate the complexity. So if you know what I'm talking about, probably you will not do the pre-master program. If you don't know what I'm talking about, probably you will do the pre-master program. It's maybe the last point is this program is running over 4 months. And in these 4 months, you have a rather intensive set of or intensive work to perform. Each of these 8 courses is equivalent to 3 ECTS credits and recognized as such by us, which means that you acquire the equivalent of minor in computer science. Okay.
Yes, and I think we have a related question to that. Ibrahim is asking if someone is not selected in the interview for the first time for the master's program, I assume, would it be possible to ask for another interview?
I'm happy to take that question. So it's not possible for another interview. So we really do, of course, take a good look at an applicant's documents, and we're very familiar with as Professor Oriol mentioned, the background that students really do need in order to be successful in the full master's program. So if we are unable to select someone for the interview, we are confident that the pre-master's program is really the best option for them in order to be able to still, at a later date, enroll in the full master's program if they do enroll in the pre-master's program and obtain a B average or above.
Thank you. Let's see if there is anything left unanswered. I think we had a question on the accreditation, which Manuel Oriol just answered in the chat function.
But I don't think that everyone saw it. So I'm happy to repeat it. We are very open about it. We don't hide anything. So the question was from Hermias, and the point was I noticed that you're not yet accredited. So can you comment about that? And the answer to this question is this: we have started the accreditation procedure. We sent various documentation in September last year, and we got formally admitted to the process in December 2023. Now, this is a long process. It takes 18 months, so we hope to be accredited in June 2025. We have good chances in the sense of we believe that we will be accredited in June 2025 because our fundamentals are good. We have good research, we have good teaching, and we have good quality procedures. If you're thinking, I want to wait for 2025, as some people might think, then one of the things I can tell you is that we're not sure that after accreditation we will have the same level of pricing, right? So this is a risk.
All right, thank you for the further clarifications, Manuel. I would say probably a final question that
maybe one more comment. As you can see, we have this culture of calling everyone by the first name. So it's in German, some people would call it the Du-Kultur. And it's nothing special. It's just the way we are. We're very friendly and open.
yes, indeed. The question from Adam that I'm addressing here is whether students work between the semesters or during the year. I can answer that. Students normally do not work. We would like them to focus on their studies. We do encourage them to take internships for in between semesters or during the summer break, or have the opportunity to write their master thesis with a company. But for the students physically present in Schaffhausen in Switzerland, we yes, at the moment they do not work basically. All right. I think we have addressed all our questions. If I missed something, please feel free to reach out to us with any further questions that you might have. You have here our email address from the Master Office. And on this note, I would like to thank you all for your participation, to our speakers, to our audience. And indeed, we look forward to having you here with us, some of you soon, hopefully, and to have you also in our future events. Thanks a lot, everyone.
Thank you. Bye.